Hey y'all. Today we're going to be simplifying numerical expressions. Still writing equivalent expressions. Remember, the whole idea of this first part of the unit is equivalent expressions, and we're still working with numbers before we move on to variables. And so today we're going to be talking about different properties that we can use to make equivalent expressions. So the commutative property, the distributive property, the associative property. We are also going to be talking about multiplicative inverse and order of operations. All right, let's start with the commutative property, and I'm hoping that you've heard about this property in the past. The commutative property, I think of commuting as going from one place to another. So the commuting distance is the same in either direction. So it's like if you were going to school, you're commuting there, and that to school is the same as to home. This works with addition and multiplication only, not subtraction or division, unless you rewrite it as addition or multiplication. So again, here's some examples. It's saying something like this. If you have 4 plus 5, we know that's 9, and it doesn't matter if you write it 4 plus 5 or the equivalent expression 5 plus 4. Either way it equals 9. Same with multiplication. 15 times 2 is 30. If you do the reverse, 2 times 15, it is still 30. So you can switch the order. You can move their location. So commuting, move the location. So that's how I think of it, moving the location. So one of the things you're going to have to do today is write equivalent expressions using the commutative property. And later, in another assignment, you're going to have to name what property is being used. So commutative property. So to write an equivalent expression using the commutative property, we're just changing the order. So I can say 3 plus 4 is the same as 4 plus 3. So please pause this and write an equivalent expression. In other words, equivalent, remember the same. An equivalent expression names the same quantity. So pause, see if you can do the next one. All right, so I wrote this as 6 times 5. So 5 times 6 is the same as 6 times 5. So these two are equivalent. Now I want to point out that for this video, while we're still working with numbers, it is easier to type the multiplication symbol as the X, even though once you are into algebra and once we start using variables, I won't use this symbol anymore. I'll always use the dot, parentheses, or no symbol at all, like 2x will mean 2 times x. But for right now, I'm using that that multiplication symbol. All right, next property, the associative property. The associative property also only works with addition or multiplication, not subtraction, unless you change it to addition by adding the opposite, or division, unless you change it to multiplication using the multiplicative inverse. So what the associative... All right, so the associative property, I think of if you associate with someone, it's like this right here. Here you can see these two are associating with one another. They're friends. But the associative property lets us change who we're hanging out with. So now these two are associating with one another. So with addition and multiplication, how they're grouped. So the way they're grouped together changes, and it works. If you have, and I'll simplify it both ways to show that they're equivalent expressions. All right, so we know that to write an equivalent expression, you're using the associative property, or changing how they're grouped together. And the reason you can do this is because adding 3 plus 7, that gets us to something with a 10. Anything with a 0 is easier to add to, plus 6. So we just associated, we changed how they were grouped together. So using the orders of operation, we would simplify what's in the parentheses first. So 13 plus 3, and this is a pretty easy one to do either way, that's 16. And we can see that if we add this together, that's 10 plus 6, which is 16. So they are equivalent even though we solved them or simplified them a different way. So you try the next one. Remember, this x does mean multiplication. And then, so pause right now, see if you can rewrite it, and then start again. All right, here's a perfect example of how this might be easier or more efficient to do this than using order of operations, because some of you might not know your 12 facts. So 12 times 5. 12 times 5 is 60, but it might be easier to have them grouped together because now you can do 10 times 6, which is 60, and it's just easier to do in our head, so it's more efficient. All right, next property, the distributive property. I will be talking to you very much over the next couple of years about the distributive property. It is a property that you use so often in simplifying or writing equivalent expressions, equivalent equations, solving equations. And basically what it says is if you have a sum or a difference being multiplied by the same thing, when I see a typo, if you have a sum or a difference being multiplied by the same number, you can multiply over the parentheses. So you can multiply over the parentheses to make an equivalent expression. So b times a plus b times y. And so this is just a visual way that you can remember they, baby. Okay, so we're multiplying over the parentheses. This, for it to work, has to be a sum or a difference. So again, how you can use this is separating. If we broke this 30 into 30 plus 6, now we can do the simple math. 4 times 30 is 120, and 4 times 6 is 24, and so we have 144. It is a simple way to do math in our heads, and we'll be using this a lot with variable expressions as well. All right, write an equivalent expression using the distributive property. We'll actually be doing this a couple different ways today. So here I see I have a sum, and so I'm going to multiply over the parentheses. So I have 3 times 10, and I can add to that 3 times 8. So I'm multiplying over the parentheses. The other way I think about this sometimes is this guy out here, he's a player, he likes to dance with everybody inside the house. This next one, as I was talking, I noticed I made an arithmetic error when I was typing this up, or a typo something, because if you notice, this right here is not a sum or a difference. So this would just be like 5 times 2 times 6. So you could use the commutative property, or you could use the associative property, but the distributive property would not work because it only works if there's a sum or a difference. So I could change this to be 5 times 2 minus 6 and do it that way, even though this would end up in a negative number, but you guys could handle that. We're not even simplifying. So please pause and write this. Distribute out that multiplication over the parentheses and see what you come up with. All right, so hopefully you distributed out the multiplication. So I have 5 times 2 times minus 5 times 6. So again, if we're simplifying this, you'd end up with a negative number, but right now I'm just concerned that you're able to write it as equivalent expression. And sometimes it is necessary to use the order of operations. That is the most efficient way. Not always, but sometimes. So I'm just going to use order of operations just to remind you. Please excuse my dear Aunt Sally. So I have my parentheses, so 2 plus 4 is 6, times, and then the next thing would be exponent, so I'll go ahead and do that, plus 5 times 4. So I can see that I could use the distributive property here. I see I have a 4 in both of my products. So I could pull out a 4 and do 4 times, and what I would be left with if I divided out a 4 here and I divided out a 4 here is 9 plus 5. 9 plus 5 is 14 times 4. So that really is not efficient. I mean, I could certainly do it, 14 times 4, but would this way be more efficient? Here I have 36, and here I have 20, and so that is easy to do in my head, 56. So in this case, using the order of operations was the most efficient way of solving this or simplifying this problem. All right, let's just look at some problems now. I didn't leave a lot of room here for this one. Order of operations would tell us that we have to go from left to right because it's all multiplication. So -1 times -3 is a +3 times 10, and then times -2 times 2. But is there a more efficient way? I think I'm going to do some regrouping here. So I'm going to do this first. So the commutative property tells us that the order doesn't matter. So I'm going to do my -1 times -3 to get 3 first. And then I'm going to do my -2 times 2, and I'm going to do that next, and I'm going to move it over to get -4, and then I'm going to do my -10. So all I did was I grouped these together, which would be the associative property, and then I moved them, which would be the commutative property. And now I'm going to multiply across left to right. So I have 3 times -4 is a -12 times 10 is a -120. So with very, very little work, I was able to group the numbers differently to multiply them because they're all multiplication. All right, for this one I want you to pause and I want you to see if you can do this in 2 different ways. So I suggest one way being just from left to right, and then see if you can use the properties to find a different way to do this. Think about the properties that we just discussed as you go through this. All right, so the first way I did it was order of operations. I just went from left to right. Right here, 24 times a -5. Well, let me start back at the top. -6 times 2, negative times a positive is a negative, and then I had -12 times -2. And notice how I rewrote everything as I went down so I didn't lose any numbers. Negative times a negative is a positive, so that's 24. And then once I got here, I had to come down off to the side because I didn't trust the arithmetic in my head. So that is a negative, because positive times a negative is a -120, and then I could do this in my head. The second way I chose is I used the commutative property first. I saw this -2 and the -5. I like to multiply by powers of 10 because that just means I'm adding a 0 to whatever I'm multiplying by. So I took this -3 and I moved it, I used the commutative property to put it in the front. So then I had this. So I could have done actually all of this. I could have grouped these together. So that would have been -6 times -6. I just chose to come straight down. It was just as easy for me. And then times 100 is 360. So either way, I came up with a 360. This way was more efficient for me because I did more of the math in my head. All right, 2 more types of problems, I think. This next one says, rewrite the mixed number as a sum and then multiply using the distributive property. So this mixed number, 5 and 1/3, remember, really just means 5 wholes plus 1/3 extra. So I'm going to rewrite that -6 times 5 plus 1/3. And then I can use the distributive property. So I'm going to distribute over the parentheses to get -30 plus -6 times 1/3. Please write this off over to the side if you need to, if you're still not very good with the fractions, because now I can see I put the whole number over, or the integer over 1, 3 goes into 3 once, it goes into 6 2 times. So 1/3 of -6 is -2. If I'm adding numbers with like signs, I add them. So there are 30 negatives plus 2 more negatives is a -32. Much easier than just multiplying like this. So I'm going to rewrite this. 9 times -3 plus, now be careful here, if we added 1/2, -3 plus 1/2, then we would actually have -2.5. So you have to remember when you split up negative numbers, negative mixed numbers, both the whole and the fractional part are both negative. So now I have -27. Remember, positive times a negative is a negative. And 9 times -1/2 is a -9/2, which is -4.5. And because these are like, I'm going to add them together. So now I have a -31.5. Much easier than multiplying, because here we would have had to put this into a mixed number and then found all that business. So this was much easier. All right, lastly, evaluate using the distributive property. Lastly on this slide. So I can see that I have a factor of 16 in both. Remember, the x here does not mean a variable, it means multiplication. So I can divide out of each of these products a factor of 16. So I'm pulling out, or I'm dividing out of 16. This takes some practice, so if you don't understand it this first time, it's okay. You're going to be practicing. So I'm going to divide out of 16. That leaves me, if I take this and take away or divide out that 16, I'm left with a -3/8 plus, and I divide out this 16 from this plus 1/4. And then I can wait to multiply by 16 while I complete this part. 2/4 is the same thing, 1/4 is the same thing as 2/8. So once I add them together, remember, you add, this is what you had on an assessment a few weeks ago, -3 plus 2. Unlike signs, you subtract. So I'm going to bring my 16 times over here. Unlike signs, you subtract. So if I had 3 negatives and 2 positives, I would be left with only 1 negative standing. And there's my 8. And then this is really easy because now I can put my whole over 1. 8 goes into 8 once. It goes into 16 twice. So now I have 2 times -1, which is a -2. So I went from something that looked very, very complicated to something that was quite simple. I would like to say before I start this next one, there's nothing quite as aggravating as going through a whole slide without hitting the record button. So this is take 2, but the first time that I'm recording it. All right, we're going to multiply the expression using only multiplication. So I rewrite using only multiplication and then evaluating. How you can change to only multiplication with division, remember, you change the division by multiplying by the multiplicative inverse or reciprocal. You're going to keep, change, flip. And what I'm hoping is that we're going to find an easy way to use our properties to simplify. So here is my division part. So I'm going to keep the first number. And remember, it's negative, don't drop that. And I'm going to change the division to multiplication, and I'm going to flip the second number. So now I have this part. The associative property allows us to group together, so change the way it's grouped. So I'm going to do this part first, since it's all multiplication. So I'm going to simplify. So 4.2 times 3 goes into 3 once, 3 goes into 6 2 times, so now -1 times 2 is a -2, and then don't forget about this end part, times -10. Now I have this decimal. I don't want to work with decimals, so I'm going to go back and change the order and do this multiplication with this. So that's the commutative property. I'm changing the order. So 4.2 times a negative 10 is a negative 42. And I just have this times negative 2 left. And that's easy to do. 42 times 2 is 84. Negative times a negative is a positive. Now, just to make sure I didn't drop any negatives, I always like to go back at the original problem. Positive times a negative is a negative, times a positive is still a negative, times a negative is a positive. So I just like checking because I tend to drop negatives. All right, so for this last one, I want you to pause, see if you can rewrite it, see if you can find a way to make it simpler. All right, so I'm going to go through my thought process. Even if you don't have the same work, if you ended up with the same answer, positive 72, and you showed all of your steps, you should be good to go. I first started by changing any division to multiplication. So I kept this, change, so keep, change, change, and then I just rewrote everything, and then keep, change, change. Flip. So these two I changed to the reciprocals. And then I looked, I had a fraction down here and a fraction down here. So I used the commutative property. First I knew that this was just going to be 3/2, and I moved that negative 2 over 1 here. So that's the commutative property. I commuted this one, changed its location. So now 2 goes into 2 once, 2 goes into 2 once. So negative 3 times 1 is a negative 3. So this part right here is simplified here. And then I had the rest of this, but I knew that if this was negative 3, it was going to be easier for me to multiply it by 3 and then by 8 versus the 3 times 8 times 3 again. So I used the commutative property one more time, changed the location, so I multiplied this part by this first and then by the 8 to give me a positive 72. All right, so what we learned is sometimes when you're multiplying and dividing, strictly using order of operations, it's not always efficient. So the properties of multiplication allow us to manipulate those expressions by rearranging or regrouping. So you have to make sure that you look to see if you want to use the commutative, the distributive, the associative, and then always go back and decide whether or not your answer is going to be positive or negative. And one way to do this is look, if there is an even number of negative factors, it's going to be positive. If there's an odd number of negative factors, your answer is going to be negative. All right, do your assignment. Let me know if you have any questions.